Hello students, myself Dr. Muhammad Ahmed. I welcome you all to the 17th lecture of Mathematics 2. Students, in the previous lecture, we have discussed what is the meaning of linear differential equation and what will be the general form of first order linear differential equation and how to solve that. So we have seen that first order linear differential equation will be of the form dy by dx plus p of x into y equals to q of x, right? This is the most general form of first order linear differential equation. For solving this, we find the integrating factor. The integrating factor is given by e power integral p of x dx. This is the integrating factor for this differential equation, and the general solution is given by y into integrating factor equals to integration of q into integrating factor. Integration is with respect to x plus c. This is the general solution for the first order linear differential equation, right, where this if means integrating factor, which is given by e power integral p of x dx. This p of x and q of x are functions of x alone or constants. So this was discussed in last class. Even we have discussed that if instead of y as dependent variable, if x becomes dependent variable and y becomes independent variable, then what will be the integrating factor and what will be the general solution, that also we have discussed in last class. Now in today's class we are going to discuss about a nonlinear differential equation which is called as Bernoullis equation, right? We are not going to discuss all the class of nonlinear differential equations of first order. Only a specific equation which is having a form something like this: dy by dx plus p of x into y equals to q of x into y power n, right? So if this y power n is not there, suppose if this y power n is not there, then this equation is dy by dx plus p of x into y equals to q of x. That is a linear differential equation of first order. Because of this y power n, the equation is becoming a non-linear. As I told you, the linear differential equation, as I told you in the last class, the linear differential equation is nothing but an equation in which the dependent variable y and all its derivatives dy by dx and d square y by dx square and so on, all these derivatives should be of degree 1. All these derivatives and the dependent variable should be of degree 1 and they are not multiplied together in any term. If this condition is satisfied, then the differential equation is said to be linear. But here you see that the dependent variable y is having power n. So that is why this differential equation is called as Bernoullis equation, and it is a nonlinear differential equation. This is called as Bernoullis equation. Bernoullis differential equation, and this is a nonlinear differential equation. This is a nonlinear differential equation. Now what we do is, as you can see in the heading, equations reducible to linear. So we try to reduce this nonlinear differential equation, which is called as Bernoullis equation, to linear equation. For that we need to take some substitutions. Let us see what those substitutions are. Okay, in first step, before taking any substitution, in first step what we have to do, because this is the term which is making this equation a non-linear differential equation. We know how to solve the linear differential equation. In last class we have discussed that if the equation is of this form, that is linear, then we have to find the integrating factor and the general solution will be given like this, right? We know this. So what we try to do is, we try to convert this differential equation to this form, right? Here you see that this y power n is an extra term. So we try to remove this. For removing this, we have to divide the equation. We have to divide, you consider this as equation 1. We have to divide equation 1 with y power n both sides. So when we do this, what will happen here? In this term we will get 1 by y power n that can be written as y power minus n dy by dx plus p of x, and here we will get y by y power n. If you bring this y power n above, what will happen? Y power minus n. So, we will get y power 1 minus n, which is equal to q of x. This y power n will get cancelled, right? We will get this equation. Now, we have to take a substitution in this equation. You consider this as 2. Now, see, in linear differential equation, if you observe the linear differential equation, here p of x into y is there, but here we are getting y power 1 minus n, right. So, we try to remove that also. For that, we take y power 1 minus n equals to some other variable z, right. Then what will happen if we take like this? Then we will differentiate this. When we differentiate this, what will happen? 1 minus n y power 1 minus n minus 1 into dy by dx. Derivative of y is dy by dx, which is equal to derivative of z is dz by dx, right. Then this 1 and minus 1 will get cancelled. So, what will remain further? What will remain? Y power minus n dy by dx is equal to, see here y power minus n into dy by dx equal to this 1 minus n I will bring here, then 1 by 1 minus n into dy by, sorry, dz by dx, right. So, what we are doing here, because this term should be removed, y power 1 minus n I am taking as z, then differentiate this. When we differentiate this, y power 1 minus n derivative is 1 minus n y power 1 minus n minus 1, and derivative of y is dy by dx, and derivative of z is dz by dx. So, finally, we are getting y power minus n dy by dx equals to this 1 minus n will come here, 1 by 1 minus n into dz by dx as it is, right. Now, you take this substitution in equation 2. So, from equation 2, you see that this y power minus n dy by dx can be replaced with 1 by 1 minus n. So, this will become 1 by 1 minus n into dz by dx plus this p of x as it is, into y power 1 minus n is there. Y power 1 minus n can be replaced with z, which is equal to q of x. Now, here dz by dx is having 1 by 1 minus n as extra. Now, multiply this equation with 1 minus n. So, multiplying this equation with 1 minus n, then what will happen? So, when we multiply this equation with 1 minus n, so this will get cancelled. So, in first term dz by dx will remain. In the next term 1 minus n into p of x into z equals to 1 minus n into q of x, right. So, this we will get by taking all the substitutions. Now, if you observe this equation is a linear, which is linear in z, right. So, we know how to solve this linear differential equation. Dz by dx plus, you consider this whole thing as a new p of x or p dash of x, 1 minus n into p of x you consider as one term into z equals to your right hand side one function of x, right, complete. So, this is a linear differential equation. This is of the form dz by dx, plus some p dash of x into z equals to some q dash of x, right, where p dash of x is 1 minus n into p of x and q dash of x is 1 minus n into q of x, right. So, this is a linear differential equation in z, right. Then what will be the integrating factor for this? Integrating factor for this is e power integral p dash of x dx, and the general solution we know, general solution is z into, general solution will be z into integrating factor, because z is the dependent variable here, not y. So, z into integrating factor equals to integration of integrating factor into q dash dx plus c. This will be the general solution. So, this is the procedure for solving any given Bernoullis equation. How to identify Bernoullis equation? It will be linear equation only. Along with that, right hand side beside q, y power 2, y power 3, y power 4, y power 5, these kind of terms are there. We have to divide the equation with y power. If y power 2 is given, divide it with y power 2. If y power 6 is given, divide this equation with y power 6, right? Then we will get like this. So whatever we are having here, that should be removed. So for that, we need to take y power 1 minus n equals to z, right? Then this term will be replaced. This term will be replaced with this term. So finally, the equation will become a linear differential equation in z, and we know how to solve that. Find the integrating factor, then find the general solution. This is the general solution for this equation. Actually, this is the general solution for this equation, but we need the general solution of this. So what we have to do, we have to replace this z again with y power 1 minus n. Then we will get the general solution here for this differential equation. This is the procedure for Bernoullis differential equation. Now we will see problems to understand what is the procedure we have to apply. So we are considering the first problem now. So first problem is solve x dy by dx plus y equals to x cube y power 6, right? So this is the given question. Now you observe that, so this equation is almost like a linear differential equation if this x is removed. If this x is removed, then this will be of the form dy by dx plus p of x into y equals to q of x. So remove this x. For removing this x, divide the equation with x. Then what will happen? This x will be removed, plus here we will get 1 by x into y equals to, from this x cube 1 x will get cancelled, from this x cube 1 x will get cancelled. So what will remain? X square into y power 6 will remain. Now you consider this as 1. So which is a linear differential, which is a Bernoullis differential equation. See, it is of the form dy by dx plus p of x into q plus p of x into y equals to q of x into y power n. So which is Bernoullis differential equation, which is Bernoullis differential equation with n equals to 6 here. So what we have to do now? We have to divide this equation. In the first step, we have to divide this equation with y power 6. So divide 1 with y power 6. Then what will happen here? We will get 1 by y power 6 into dy by dx. That can be written as y power minus 6 into dy by dx plus 1 by x. Here we will get y by y power 6. So 1 y will get cancelled, 1 by y power 5 will remain. If you take that above, we will get y power minus 5 is equal to x square into this y power 6, and y power 6 will get cancelled. So we will get this equation. Now what we have to do? Whatever is there beside p of x, that should be taken as a substitution. Here we are having y power minus 5, so take that as a substitution. So put y power minus 5 equals to z. Then what will happen? Differentiate this, right? You consider this as second equation. Now in this equation we are making this substitution. In this equation we are taking y power minus 5 equals to z. Now differentiate this. When we differentiate this, y power minus 5 differentiation is minus 5 into y power minus 5 minus 1 into dy by dx equals to dz by dx, right? So this implies what we will get here? Y power minus 5 minus 1. Here y power minus 5 minus 1 is there. We will get y power minus 6, y power minus 6 into dy by dx equals to, what will happen? This minus 5 will come here, right? So it will be minus 1 by 5 dz by dx, right? We will get minus 1 by 5 dz by dx. So now take this substitution in equation 2. So what will happen? Y power minus 6 dy by dx. This y power minus 6 dy by dx will become minus 1 by 5. So minus 1 by 5 dz by dx plus 1 by x as it is, and this y power minus 5 will become z equals to x square, right? We need to remove this minus 1 by 5. So I'll multiply this equation with, I'll multiply this whole equation with minus 5, right? I'll multiply this whole equation with minus 5. Then what will happen? This minus 5 will be removed, minus 1 by 5 will be removed, dz by dx minus 5 by x into z equals to minus 5 x square. Now you see this carefully, that this is a linear differential equation which is linear in z, which is linear in z. Now what is p of x and q of x here? Here p of x equals to minus 5 by x and q of x equals to minus 5x square. We know how to solve this. If the equation is linear, then we know the procedure for solving this. What we have to do, we have to find the integrating factor. Integrating factor is, we have to find the integrating factor, which is integrating factor equals to e power integral p dx. So this is equal to e power integral, what is p now? P is minus 5 by x, minus 5 by x into dx. This is equal to e power minus 5 can be taken out, 1 by x will remain. Now integration of 1 by x is log x, right? E power minus 5 log x. This can be written as e power log x power minus 5, right? Exponential and log will get cancelled, x power minus 5 will remain. X power minus 5 is nothing but 1 by x power 5. X power minus 5 is nothing but 1 by x power 5. This is the integrating factor now. Integrating factor is 1 by x power 5. Once we get the integrating factor, we have to find the general solution. So the general solution of equation 3 is, because we have found the integrating factor for equation 3 only, the general solution also we will get for equation 3 only. So general solution of equation 3 is, what is the dependent variable here? Z is the dependent variable. So z into integrating factor equals to integration of integrating factor into q into dx plus c, right? So z into, what is integrating factor? Just now we got the integrating factor, it is 1 by x power 5. So it is 1 by x power 5 equals to integration 1 by x power 5. What is q? Q is minus 5x square. So here we will get minus 5x square into dx plus c, right? Now minus 5, we have to integrate this. This z into 1 by x power 5 will be as it is. We have to find the integration here. So this is equal to, this is, or I'll write here, this is equal to, minus 5 can be taken out, integral. You see here x power 5 is in the denominator and numerator x power 2 is there. So x square will get, x power 3 will remain here in the denominator, x power 3 will remain. If you bring that above, it will be x power minus 3 dx plus c, right? Now we have to find the integration, minus 5 into integration of x power minus 3, x power minus 3 plus 1 by minus 3 plus 1 plus c, right? So finally what will get, z into 1 by x power 5 equal to, here you will get minus 5 here and minus 2 here, minus 5 and minus 2, that will become plus. So 5 by 2 we will get, 5 by 2 into, here x power minus 2 we will get, minus 3 plus 1 is x power minus 2, that can be written as 1 by x square plus c. So this is the general solution of equation 3. Now to get the general solution of given equation, we have to substitute back the value of z. Therefore general solution of 1, that is the given equation, general solution of 1, for getting the general solution of 1, whatever the substitution we are taking, that we have to substitute back, right? What we have taken? Z equals to y power minus 5 we have taken, z equals to y power minus 5 we have to taken, that we need to substitute back here. Z equals to y power minus 5, so y power minus 5 into 1 by x power 5 is equals to 5 by 2 into 1 by x square plus c, or this can also be written as 1 by x power 5 and y power 5 equals to 5 by 2 x square plus c. This is the required general solution for the given differential equation, right? This is the required general solution for the given differential equation, right? So what we have done, let us understand this once again. So if the given equation is of this form, dy by dx, x into dy by dx plus y equals to x cube into y power 6, right? This will become this will be in the form of dy by dx plus p of x into y equals to q of x if you remove this x. So that is why I am dividing this equation with x, then I will get 1 by x here and x cube will become x square. Now this equation is of the form dy by dx plus p of x into y equals to q of x into y power n, right? This equation is called as Bernoullis equation and the value of n here is 6. So first, in the first step we have to remove this. For removing this, divide the equation with y power 6, then we will get y power minus 6 here, dy by dx plus 1 by x, y power y by y power 6 is nothing but y power minus 5 equals to this y square, y power 6 will get cancelled, x square will remain. Now we have to take this as substitution. To make this as linear, we need to take y power minus 5 as a substitution, that y power minus 5 equals to z. Then we differentiate this, finally we will get this equation, which is a linear differential equation in z, where p is minus 5 by x and q is minus 5 x square, right? Find the integrating factor, we got it to be 1 by x power 5. Then general solution for this equation 3 will be z into integrating factor equal to integration of integrating factor into q dx plus c. Substitute the integrating factors here, simplify, we will get the solution of equation 3. To get the solution of equation 1, whatever the substitution we have taken, that is y power minus 5 equals to z, that we have to substitute back here, then we will get the required general solution, right? So this is the procedure for solving Bernoullis equation. I hope you have understood this, how to identify Bernoullis differential equation and how to solve that. The simple procedure identification is that this equation will be, Bernoullis equation will be same as linear equation only, dy by dx plus p of x into y power, p of x into y equals to q of x into y power n, extra term will be there, right? So to remove that, divide the equation with y power n, then we will get one extra term that has to be taken as substitution, then equation will become linear. So what we are doing, a non-linear equation is reduced to linear equation, then find the general solution, and to get the solution for Bernoullis equation, whatever the substitution we are taking, that has to be substituted back, then we will get the required general solution for the Bernoullis equation. This is the procedure, very simple, and it is important for one LEQ question in the examination, right? This is very, very important for examination purpose. I am going to end this session here. See you in the next class. Thank you.